end, so I can help answer a few questions. But Anchit here is on the data science side, and he'll be walking through the meat of the presentation today. So with that, I'll let Anchit take over.
All right. So using Hal9, we wanted to build a system that can easily. We want to develop a solution that to do the entire data science pipeline in browser using JavaScript. So this would allow the end user to easily embed data analyses in any web page that supports static HTML, like Wix, WordPress, or anything, you name it. Additionally, using Hal9, the end user can also very easily deploy full AI solutions into any static web page as well, developed using any of the earlier mentioned services. So now the main question arises, why use JavaScript at all? So before we get into the specifics of JavaScript, let's talk about why. Let's talk about what some of the other languages that are normally used for processing data in data science and machine learning are. So the most popular language is Python. It's the most widely used programming language for data science and machine learning. According to Guido van Rossum, the creator of Python, from one perspective, you can say Python is a very high-level scripting language. From another perspective, you can say that Python is a very high-level programming language that happens to be implemented in a way that emphasizes interactivity. Python shares some characteristics with scripting languages, but also shares some characteristics with more traditional programming languages. Additionally, Python also has a very large open source community, which has developed popular data science packages like NumPy, Pandas, scikit-learn, which make going through the entire data science pipeline in Python a breeze. Another popular language for data science is R. So R is a free software environment for statistical computing and graphics. It compiles and runs on a wide variety of Unix platforms, Windows, and Mac OS. It's primarily written in C, Fortran, and R itself, and is freely available under the GNU General Public License. So R is a language that is created for statisticians, created by statisticians for statistical analysis. It is a functional programming language, making it really easy to do data analyses in R. My favorite feature in R is probably the pipe operator, which allows you to do consecutive operations on a data frame, which popular Python packages like Pandas have replicated using the dot operator. So the next most popular language in data science is Julia. So talking about why Julia was created, Jeff Bezos, the CTO of Julia Computing, said, "We want a language that's open source with a liberal license. We want the speed of C with the dynamism of Ruby. We want a language that's homoiconic with true macros like Lisp, but with obvious familiar mathematical notation like MATLAB. We want something as usable for general programming as Python, as easy for statistics R, as natural for string processing as Perl, as powerful for linear algebra as MATLAB, as good at gluing programs together as the shell. Something that is dirt simple to learn, yet keeps serious hackers happy. We want it to be interactive and we want it to be compiled." So now this brings us to JavaScript. Well, unlike the other three languages, JavaScript does not really have a canonical developer or someone who you can credit with it being the creator of. So according to Computer World, JavaScript was aimed at aimed to provide a glue language for web designers and part-time programmers who were building web content for components such as images, plugins, and Java applets. We saw Java as the component language used by higher-priced programmers, whereas glue programmers, the web page designers, would assemble the components and automate their interactions using a scripting language. So, unsurprisingly, as this data set from, as this graph from Stack Overflow shows, JavaScript is the most popular language. For the 8th year in a row, JavaScript has maintained its stronghold as the most commonly used programming language. Going further down the list, we see moderate gains for TypeScript, edging out C in terms of popularity. Additionally, Ruby, once in top 10 as recently as 2017, has declined and has been surpassed by trendier newer technologies like Go and Kotlin. But this is not to say that JavaScript is perfect by any means. It can have weird and idiosyncratic behavior. For example, let's take a look at this demo. So, what do you guys think happens when you try to add 2 arrays in JavaScript? Feel free to unmute yourself or drop something in the chat. All right, I guess no one wants to guess, but I would expect a type error here because adding 2 empty arrays, that doesn't really make sense. But instead, what we get is an empty string. Now let's see what if we were to add an empty array and an empty object, or like a dictionary. I guess in JavaScript, the symbol is for an object. Well, we get an object, which is an object. But now, because this is a addition operation, you would expect that it should work the same way if you do it the other way around as well. But surprisingly, it's the integer 0. And now let's say you want to do an object plus an object. Well, this one, I guess, anyone might want to take a guess. It's not a number, which I guess is technically correct, but that is not the behavior I would expect at all. So, going back, JavaScript, as we can see, is not a perfect language. But despite that, it remains. So we come back to why JavaScript. The first reason for using JavaScript is that it's super easy to create highly interactive materials that are lightweight to be used inside the web browser itself. For example, every Chrome installation comes with this Dino game, which you can see here. It's a really simple animation, and I guess I'm just bad at this game. But yeah, so this is super lightweight, it's interactive, and it's easy to make in JavaScript. Additionally, JavaScript has one of the best environments for development. You can build using JavaScript. You can build apps reactively and use this highly interactive and feature-rich development environment to create apps easily. Using JavaScript, you can see the changes you make in code as you make them. Additionally, with the rise of Chromebooks and Chrome run tablets, which are essentially browser-based operating systems, they can run JavaScript natively. So using JavaScript for data science and machine learning can allow us to reach these devices and create services that can run natively on these devices. Another reason why we think JavaScript is a super cool environment for creating apps and for doing data science is because of the rise of Node.js. With Node.js's just-in-time execution of code, you can actually achieve data processing speeds that are faster than Python. As you can see, these guys at Rising Stack created microservices that can reach millions of users using Node.js and help cut down processing time by removing the bottleneck of having you transfer all your code to the server and come back. And as we were talking about, it's really easy to make interactive apps in JavaScript. Here's another really cool demo. This is all being run natively in the browser, and all the processing is being done on the client's end. And so you can see this is a really cool animation. And it's all interactive, and all the processing is being done in my browser instead of somewhere off on a server. All right. I guess moving on. We have another really cool demo. So how many guys ever played Doom? I remember Doom because it was literally the first game I ever played on a PC. And using JavaScript, people have been able to easily port over Doom to run in the browser. You can see it runs completely fine. You can move around and essentially play the entire game, all of it, in your browser. So as you can see, JavaScript makes it really easy to build interactive apps that can run completely in the browser. Additionally, some new technologies and some new projects such as Johnny5.io use JavaScript to execute code on the edge. So you can use Node.js and Johnny5, for example, to build JavaScript code that is executed on like these tiny processors such as Arduino, or Raspberry Pi, Tesla 2, or Intel Edison, and have it all be. So using JavaScript for data science and machine learning allows you to do AI on the edge using very low-cost components. And this is all the images in the presentation link to the websites. So if you ever want to go back and look at it, I'll share the presentation, and it should be pretty easy. But so all this is good, but what really motivated us to investigate data science in JavaScript was the development of the TensorFlow.js library, which is released by, I guess the first version was released by Google back in March 2018. So TensorFlow.js brings some of the capabilities of the very familiar to most machine learning engineers and data scientists library of TensorFlow to JavaScript. Using it also brings with it the high-level Keras API and the TensorFlow Core API. So you can easily build machine learning product models that can be executed client-side in the browser using WebGL. So here are some really cool demos. My favorite one is probably this. You can, I can like train a model in browser, and now I can play Pac-Man using just my head as a controller. Again, I'm pretty bad at Pac-Man. But yeah, so as you can see, JavaScript, TensorFlow.js allows you to do really cool stuff in the browser. And additionally, with the growth of, with the starting of TensorFlow.js, the JavaScript, the nascent, I guess, machine learning community in JavaScript is also striving. If you want to learn more about how to use TensorFlow.js, I would recommend this book, Learning TensorFlow.js, published by O'Reilly, written by Gan Lavort, who is one of our advisors. Now, moving on to actually doing data science with JavaScript. So I think we're all familiar with the data science pipeline. Normally, I guess it's not 100% accurate, and obviously in real life it's much more complicated. But on a completely abstract level, we can define the pipeline as essentially importing some data, transforming it, visualizing just to make sense of our data, and training a model, using the model to predict something and explain it, and finally export it to run somewhere. About a month ago, we released this quick article. It's just a 2-minute read that basically summarized our entire experience as we learn what JavaScript is good at and what JavaScript struggles with. So I guess importing stuff with JavaScript is really easy because especially when it's data from the web, because of services like Puppeteer. Next step in the pipeline would be visualizing. JavaScript is really good at visualizing data. The most popular library for visualization today probably is D3. D3.js is a JavaScript library that is used for manipulating documents based on data. It lets you build really interactive models that run in browser, and the creators of D3 have also created this website called Observable, which essentially lets you create interactive notebooks using JavaScript to create visualizations in the browser. As you can see, we have a few models here. It's really easy to create visualizations and visually appealing visualizations in JavaScript using just simple libraries like D3 and chart.js. So talking about transforms, JavaScript sort of struggles a bit more with transforms. One of the first libraries we explored for transformations was tidy.js. So tidy.js, for those of you who are familiar with R, was inspired by the dplyr and tidyverse in R. It uses very similar verbs using R, and the first, I guess, iteration of Hal9 that we built use tidy.js because it works very well with plain JavaScript objects. However, it has very real limitations, as we found out. It slows down a lot as soon as you reach around 10,000 rows worth of data, which is, I guess, good, but it's not ideal. So we started investigating other libraries. One of the ones we investigated, and I guess we still use, is Arquero. Arquero, again, is also inspired by the design of dplyr. It provides like a it provides us with a columnar data frame, which is similar to the data frames used by pandas and in Python and the data frames in R. But so this actually was a huge performance breakthrough. Using Arquero transformations, we can easily work with data that's close to 1 million rows. However, Arquero is also not a super easy to use library. Writing Arquero code can be very idiosyncratic. So Hal9 provides an easy to use wrapper around Arquero, which lets you transform data as you use it. So I guess here we're using Arquero and to derive new columns or rework existing columns using Hal9 in this presentation, in this pipeline that we use to create this visualization of how COVID-19 affected travel in the United States. As you can see, and I guess a lot of people are familiar with air travel in 2020 saw a very sharp decrease when we first went in lockdown, and all that slowly has recovered since and really picked up pace in since like March 2021. It's still not at 2019 levels. So yeah, another limitation of Arquero is that it doesn't really work well with TensorFlow.js because TensorFlow.js expects either the input to be tensor. To create tensors, you need to go back from Arquero to the native JavaScript object and then to TensorFlow.js tensors, which creates a huge bottleneck. So another library we investigated was Danfo.js, which is, I guess, more heavily inspired by pandas as opposed to the earlier two, which were more tidyverse inspired. And it builds on top of TensorFlow.js tensors. So going from columnar data in from Danfo.js data frames to TensorFlow doesn't have the same bottleneck. However, as we were at least 2 months ago, and this supposedly has changed with the latest release of Danfo.js. I haven't been able to test it myself and confirm it, but this is what the authors, the creators of the library told me. Danfo.js used to have a huge bottleneck in data frame creation. And although the latest patch notes don't say it, but that is a problem that it should have been fixed with the latest release. So in the future, we might go back. We might go back and look at Danfo.js and see if the performance is comparable to Arquero and maybe make the switch. So now moving on to the train part of the data science pipeline. So the two biggest libraries for training models in JavaScript are TensorFlow.js and ML5. ML5 is a friendly machine learning environment, which which has a really approachable API to create models for web. TensorFlow, on the other hand, is a tried and tested library that actually supports conversion from pre-trained models, even in models trained using Python TensorFlow to execute in the web. Additionally, we also have some new libraries like like JStats, which are developing, which are coming out. So it's definitely an exciting time to be working with JavaScript. So now moving on to exporting data, exporting the models and the predictions that you've made. So HTML5 is HTML5 is probably the easiest way to integrate models into a web page. React also has a really cool way of incorporating data science models into JavaScript applications. So finally, if you look at the entire pipeline for transformations, Arcaro, Danfo.js, and Tidy.js are probably the best used libraries. Visualizing for visualizing data, JavaScript's that's probably the part of the data science pipeline that JavaScript's best at. We have well-developed libraries and highly supported libraries like Chart.js, D3, and Plotly, and obviously the observable notebooks. For training models and predicting, TensorFlow.js remains by far the best resource. Although, as we discussed earlier, there are bottlenecks in using TensorFlow.js, especially because there isn't a very well-developed system of supports. That there isn't like a common vocabulary, like in the case of pandas, like in the case of Python, where you have pandas, NumPy, scikit-learn, which are always supported by each other, and Matplotlib. So you have like this common vocabulary which packages know they have to support. On the other hand, in JavaScript, this level of maturity isn't there. So that probably remains the biggest bottleneck in doing data science with JavaScript. But this bottleneck can be solved with the development of new technologies like Pyodide, which let you execute Python code in browser using WebGL. So, for example, here we have the Pyodide interpreter. Now I'm basically able to write any Python code. Create a write any Python code. And it works. And this is all being executed directly in my browser. So I would say that that's probably the biggest advantage of JavaScript, that you can execute everything in browser. So you can so that is really useful in scenarios where you have security risks, and you want to ensure that data exists only on client side instead of having to host everything on a server. And so Hal9, although we have all these packages, Hal9 is a one-stop resource where we can do the entire data processing pipeline in one place. So to demonstrate this, I would like to show you some demos. that we of some pipelines that we've created in Hal9, which can also be found very easily by going just to Hal9's website. So one of the ones we have here is basically doing basically building a simple regression using TensorFlow to TensorFlow.js to do a linear an exponential regression on a single variable to predict the increase in temperatures using recent data. So we basically pulled CSV data from NOAA.gov's the website. Then we filtered it to have only temperatures from temperature differences from starting at 1888. Then we converted everything to actually get it to parse as a flow. This was back when we were still using tidy.js and the native JavaScript objects, and using D3, we can create this scatter plot and eventually add a regression model to that using TensorFlow. Another really cool pipeline that we have here is we did an analysis of posts about GameStop on the popular Wall Street Bets subreddit. So here we found a CSV file which sort of had all the posts for a 2-week period in made on Wall Street Bets. Then we used a map to we used a map block to label the post as whether it was about GME or GameStop or other stocks. Then we created a scatter plot. Here we can see that GME posts definitely had a lot more upvotes and a lot more comments than most other posts. Most other, if you look at orange ones, they're normally in the lower sides, and the blue dots, which represent the GME posts, are scattered slightly higher. Then using TensorFlow.js, we did some sentiment analysis using the pre-trained model to predict the sentiment of the title. As you can see, and this is probably the most interesting result we found, was GME posts either are very negative or very positive, and they have a lot more comments compared to other posts which are very negative or very positive. So as you can see, I think this might because GameStop, especially during at the peak of its hype, had a lot of ardent defenders on Reddit. Another really cool visualization we did was using pose detection to measure like how many people there are using machine learning in a album of pictures taken by Brandon Stanton for his Humans of New York photo blog. Here we used Hal9 to very easily import data by scraping it from an Imgur library. Then we used the BodyPix pre-trained model which uses ResNet50 as its base, as its underlying neural network to predict the position of different body parts. And then we use that to count the number of people in every image. And then we can create a gallery, which makes it really easy to export things to be published into your website. So as you now, I would like to give you a quick demo. This is the one of the, I guess, the most used on data sets, the iris data set in data science, which people use just as like sort of, I guess, the hello world of data science. Doing any sort of transformations in HAL9 is as easy as dragging and dropping a certain block into place. And using this, you can build entire data science pipelines. Let's say I want to filter things of sepal dot length which are greater than 3. I guess 3 would include most of them. So 4. Or 5. Okay, yeah, 5 is, I guess, easier to see. And then I can do any sort of transformation here. Then I can create a really cool visual graphics using either like a bar chart or let's say I want to build a scatter plot. And then the color, let's say I want every species to be in a different color. We can kind of get really cool visual information, and then I can easily build, let's say, a simple regression model on this data. And you can see it's obviously not the most correlated data, but you can see a slight negative correlation between sepal length and sepal width. All right, so I guess that brings me to the end of the presentation. I would like to ask if you have any questions.
Hey, Anchit, can you hear me?
Yeah.
Hey, what about big data sets? If you have those, will you run into issues here?
So using Arcaro, we've been able to work with data sets that are as big as about a couple of million rows very easily in the browser. But beyond that, yes, you're probably going to run into some issues.
Okay.
And obviously, the libraries in the JavaScript are still pretty new, and a lot of them are seeing rapid iteration. So obviously, this number could change. But we've been able to run a million rows pretty easily in the browser. And but if you want to go beyond that, at a couple of million rows, it's kind of stretching it, and I haven't been able to get it to work beyond 2 million rows so far.
Okay. Okay. And how about mapping and stuff? Suppose if you have lat long data, can you map those 1 million or 2 million records and visualize it that way?
So we've tried doing that, but visuals, the visualization, at least in using the libraries we have been using, don't look the best past a couple of maybe like 10,000 points. So you could technically do it, but it's just not something that looks visually appealing at that point.
Okay, so you would say 10,000 points, you would be able to see it on a map, no issues.
Yeah.
Okay. Cool. And so the tool also lets linear regression, logistic regression, random forest, all those I mean, will it pick the best algorithm and stuff?
So we haven't implemented regression trees yet.
Okay.
But yes, that is something that is on our plate. And I don't think there is anything close to as good as XGBoost or for JavaScript. So that is something that we would have to develop ourselves at Hal9. So that is just not something we thought would be super useful in the beta, because I think for most it is definitely something that should be done, but it just wasn't something that's super easy to do straight off the bat in JavaScript.
Okay.
So Harry had a couple of questions in the chat. I'm going to answer real quick. Yes, I will. I've already sent, I guess, a copy of the slide deck to. I'm sorry, I'm blanking on the name.
Yes.
To Siddharth.
I got it, yeah.
So I think Siddharth can share it with all the attendees. Otherwise, you can always reach me at. Here is my email, and I can send you a copy. So Hal9.com seems to be down because that's where we plan on launching our beta, which is coming up real soon, in a couple of weeks. If you want to try using Hal9 right now, what I would suggest is you go to hal9.ai, where you can play with our alpha, or alpha.hal9.ai/index, if you want to just get to playing with the product itself without having to go through the sign-up page. And yes, as Harry mentioned, TensorFlow does use WebAssembly or WebGL for doing math-heavy ML processing, which is sort of what these demos we're also using, especially the port of Matzelle one. And obviously, yeah, you can train models using TensorFlow as well. But in my experience, TensorFlow.js is good at training and building models. For example, we used a LSTM to do Bitcoin prediction here, and this basically we train a LSTM using TensorFlow.js, and then we can simulate it, build a linear prediction, which can sort of shows you how it's predicts a dip right here. So Devil is a if you wouldn't use Devil, the Hal9, that is where that is the development environment, and that has, I guess, the beta on it. That is the new. I guess you get to see a new preview of the interface that we're building, but obviously it's a development environment, so it is not the most stable. Alpha is a stable environment, but Devil gets like daily updates, so it might break at any time. So I would recommend just using alpha.hal9.ai for now. It's just a matter of a couple of weeks before the beta is launched to everyone. For browser-based visualization tools, I guess no, I'm not quite sure what you mean by if I have a preference for browser-based with tools. Like I personally am not super good with visualizations. I wasn't the person who wrote any of the visualizations. We've been using a mixture of D3 and Plotly for our visualizations. Most of them use D3. As you can see, this uses D3. And I think D3 is also the most popular and the most used and well supported of the libraries. So, which is why I think we made the decision to go with D3 for now. I think we do use some other libraries when it comes to, for example, we have a map plot here, which uses leaflet to create map. So this is a pipeline which essentially plots earthquake epicenters on a map. So similarly, we also have another pipeline which does LA bus stops, and these both use the same map block, which is written using leaflet. Are there any other questions? So currently there are no integrations with other editors. Right now it's a completely web-based IDE. If you want to edit any of the blocks, you can basically just turn on developer mode, and it lets you edit any of the scripts. And if you're interested, we also have a open source repo, github.com/Hal9 which the open source, which basically is, serves as an open source wrapper for all the libraries you were talking about. Feel free to create new scripts if you want to for transformations, or visualizations, or new prediction models, and you can create and you can commit, create a pull request, and I guess we can merge them. So obviously for this, like you could clone the entire repo on your computer, clone the entire repo, and then use any editor you like to test if it works. I personally use VS Code, but yeah, I actually almost prefer working on the web editor because it works reactively. So any change I make in the code, I can see what effect it has on the visualization or the transformation as I make the change. So I find that really useful. So I personally prefer just using, if it's like a small change, just doing it in the browser itself.
Okay, Anchit, yeah, thank you very much for the talk and the demos. It looks like this is a very exciting technology that's just about to, be released, and you're really targeting, the common folk, not the big corporate customers, but actually anybody who, like say knows JavaScript and is interested in doing data science. And it looks like you've put together a real kind of a guide to tell them what to do and what to try. So again, yeah, thank you for the presentation. I will be posting that link to your slides on the Meetup website. And with that, yeah, thanks for attending.
All right.
Thank you, Anchit. Yeah, very nice. So interesting, very interesting.
You're welcome.
Okay. Bye.
All right.